You're live.
Very good. Welcome, everyone. Thanks for joining us. We'll give everyone a couple minutes to come in and then get started. Great. Well, we still have a few more people coming in. Let's give them one more minute and then we'll kick things off. All right, well, let's get started. Welcome, thanks for joining us today. Welcome to our second panel on advanced catheter manufacturing. My name is Barry Schnur. I'm the CEO of David Schnur Associates. And on behalf of the DSA team and our partners, I want to thank you for joining us today. We've got a tremendously experienced and accomplished group assembled for you. While Zoom has been great, I was excited to meet with most of our DSA team earlier this week in real life. We're really happy to be out and visiting with you again and hope to see many of you in August at MD&M West to continue these discussions. Today, we hope to provoke some meaningful technical discussion on processes and components for interventional delivery systems and devices. As many of you know, this has been a core focus of David Schnur Associates for over 40 years. I'm going to take a few minutes to introduce our panel, some of their core capabilities and technology focus, and how that fits into our topic for the day. We'll then have a focused individual discussion before moving into a panel format on key challenges and then on to your questions. A few quick housekeeping items. First, you can ask questions at any time at the bottom of your screen. While you cannot chat with other attendees, you can always get help from the DSA team by raising your hand or sending the panel a chat. Lourdes Brewer, our coordinator, will be keeping an eye out and moving things along. After the panel, we will send you a quick note along with a small survey. We are planning more content and would really value your feedback on this session. Finally, your local DSA technical representative can be reached either through our website or with a response to that note. If you haven't met them yet, in person or on Zoom, I think you'll appreciate the role that they can play in addressing some of your challenges. Now, on to the panel introductions. Tom Barrett has been the CEO of Applied Plastics since 2019. Tom has over 30 years of experience working in both medical device OEMs, as well as contract manufacturing companies for medical devices. An engineer by training, Tom has a broad background in product development, manufacturing, and commercialization of products. And something about Applied Plastics. Applied Plastics' proprietary PTFE natural coating has been the gold standard for use in process mandrels due to its superior release, unique surface profile, and consistent diameters. Today, we'll talk about that technology and how it's being applied to a new range of medical devices and applications. We'll also address some of the cost and availability issues around mandrels and coatings, and take any of your questions on comparable polymers. Tom, thanks for joining us today.
Good morning, Barry. Good morning, good afternoon, everyone, and glad to be here. Thanks for asking.
You bet. Noel Taylor has been working with entrepreneurs, designers, and established design teams in the medical device industry for over 25 years. In his newest venture as CEO and co-founder of Forinno, Noel and his team strive to fill the niche needs of the medical device industry. Prior to founding Forinno, Noel was Vice President of Engineering at Confluent and a co-founder of Modified Polymer Components. Utilizing their unique technology for polymer forming and molding, Forinno offers solutions to challenging products centered on polymer tubing components and assembly services. Today, we'll highlight their experience with high-temperature engineering plastics and fluoropolymers and how those products can be used in unique, thin-walled, and complex devices and subassemblies that most other manufacturers do not want to tackle. Noel, thanks for joining us today.
Thank you, Barry. Appreciate being here. Hello, everybody.
Michael FASCI is the Senior Vice President of Manufacturing and Technology at ACME Monaco Corporation. With over 35 years in the organization, Mike has responsibility for manufacturing, R&D, and IT. In his current position, he heads ACME's new product development and patent efforts, but has done everything, including coordinating the company's original ISO 9001 implementation. A little bit about ACME. Established in 1947 in Connecticut's industrial heartland, ACME Monaco has grown from a specialty manufacturer of springs, coils, and stampings into a global FDA-registered medical device company supplying a range of guide wires and components. Offering a tremendous range of standard and custom wires and stylets, ACME provides millions of wires to some of our industry's best-known companies. Today, we will be talking about some of their newest products available for medical device OEMs and how guide wires and other proprietary products differ from custom components. Mike, thanks for joining us today.
Thank you, Barry. It's great to be here, and welcome to all the attendees.
Thank you. Mark Sorensen is the Chief Technical Officer of M3 Precision. Mark's a master machinist and an entrepreneur. He's been working in the medical device, aerospace, and other advanced industrial businesses for decades, focusing on the use of Swiss screw machines and related devices to produce complex, high-precision components. M3 has 2 facilities in California with different capabilities and focus. In Goleta, Mark's screw machine business has invested in extremely complex multi-axis equipment to produce amazing components in metals and plastics. Their Santa Maria location focuses on smaller volume, highly complex machined assemblies utilizing EDM, multi-axis milling, surface grinding, and assembly processes. We'll be talking with Mark today about those capabilities and how M3 has worked to make them accessible during design and scale-up of smaller processes. I hope we provided some useful context for you. Now onto the detail that you've been waiting for. Let's start with applied plastics. Tom, I wanted to just, obviously we teed this up to talk about PTFE coatings and PTFE natural in particular. What should design and manufacturing engineers look for in a PTFE coating when they're thinking about process mandrels? And can you talk about differences between the various coatings offered by different companies?
Sure, thanks, Barry. You know, obviously the design and manufacturing engineer really must assess what's important in their process. What are the typical, attributes they're going to need to, develop a successful catheter and manufacturing process for that. So we typically get challenged around, features such as, durability. So, how durable is the coating and the mandrel going to be as part of their manufacturing process? What's the lubricious features and how much PTFE is in that mandrel? How smooth is that going to be? And obviously that leads right into those specific release characteristics. So, whether it's static or dynamic release, is it going to be sufficient for, for the type of process that they have involved? Heat resistance, so obviously depending on the process, you're going to see various heat impact on that process and on that mandrel. So it's very important to understand, what are the temperature variations, what are you going to see, and how will that coating, stand up to the process. And lastly, it's probably around, tolerancing. So can you use a supplier that's going to deliver tight and consistent tolerances? So what can your design accept? How tight of tolerances do you have to have? Typically, we're, making mandrels around, plus or minus 0.3. Do we typically, are we asked to go, tighter than that, plus or minus 2? Absolutely. Where we have to, and where obviously space is at a premium, we can manage those tolerances. In certain circumstances, we've been challenged to, hold tighter tolerances. So obviously, that's not the majority of our demand, but if we have the right diameter and the right controls in place, we can even hold tighter than that. So again, those are some of the key features and attributes of the process that the design and the manufacturing engineer really needs to think through as they select their coating supplier. From the market standpoint, clearly, there's differences in the PTFE suppliers in the market. A lot of that has to do with probably the type of processes they use, the type of coatings they use. Applied Plastics has been around and focused on the application of PTFE for, over 60 years. So we have a lot of experience in the application and obviously specifically in the application to the use in medical. So we've been, in the medical field for over 30 years, really focused on, the applications of PTFE. So the difference is, again, lubricity that we see in terms of how much, PTFE is in your coating. We talk a little bit about PTFE natural. PTFE natural is a clear PTFE coating. So, anytime you can put in, less colorant, you're going to be able to put in more PTFE. So we'd like to think that our coating has a high amount of PTFE and as a result is very lubricious. The other things we need to look at is durability. Again, the type of coating you put on. What's that?
So,
go ahead.
I was just going to ask. So, I mean, it's not just a difference in terms of the absence of a color, but right. We think as in the application process, in the process of applying this product to the mandrels as well. I mean, there's a clear, for anyone who hasn't seen it, if you take a PTFE coated mandrel or wire from Applied Plastics and you compare it, you will absolutely notice right away the difference in the surface finish, in the material itself.
Absolutely. Yeah, and it has to do with a lot of those things in terms of the preparation that we use and the coating process that we use, you know, the thickness of the film we're able to put on. All those things are part of, you know, delivering what we think is the most lubricious, you know, mandrel available in the market today. And that also leads into, you know, the durability. So, you know, we have very tight tolerances and can put on a very consistent thin layer of PTFE, which, you know, through the curing process becomes very, very durable and is very strong. And obviously as well, you know, our process of application, which is proprietary, is really focused all around adhesion as well. So the ability to really promote excellent adhesion, which obviously goes right in line with durability and the continual use and repeated use of the mandrel in the process. You know, we think these characterization and characteristics of a good, you know, mandrel coating really add value to our process. And, you know, we've heard time and time again that the applied plastics mandrel can last, you know, multiple times longer than some of our competitors.
Right, so even if there may be some difference in terms of cost or other things, that tends to be made up for sure in reuse and other.
Absolutely. We've heard, you know, a variety, obviously, depending on the process, we've heard, you know, 2 or 3 times to 5 to 7 times to even multiple, you know, times higher than that, again, depending on the application and the use. And, you know, so we definitely think from a value perspective, when you look at it for the number of uses, you know, we definitely feel that the applied plastics is a valuable, you know, asset to anyone's manufacturing process.
Great, thank you. Yeah, you know, particularly in early stages, R&D people and manufacturing engineers, as they're locking design and process in, need to iterate very quickly. Early stage device development, early stage manufacturing rollout. That accessibility of product is really important. What have you guys done to accelerate delivery of standard and custom coated products there?
That's a great question, Barrett. And clearly, you know, as the engineers face these development timelines on their new catheter, the new delivery systems, you know, speed is critical, right? So speed is the challenge to be able to, you know, compete and get out new iterations and get to your final design faster. So the last few years, we've really focused on, you know, 2 main areas. The first being in 2020, we opened an online store. So currently we have, you know, over 100 sizes of PTFE natural coated wire from 7,000s to, you know, 70,000s available in stock, whole sizes, and then from, you know, 7,000 up to 45,000s in half size increments. What's great about the store is it's really easy to use. It's available for you. So, you know, you go online, you pick your size, you put it into your, you know, your shopping cart, and with a credit card, you can have stuff shipped out same day. So we're very focused on making sure we have ample inventory in there. Ship out same day, can be on your desk the next morning. Whether you need 3 sizes, 5 sizes, 1 size, it's available for you to select and use in your design iteration. So we think that's really been a help for a lot of the development engineers and the manufacturing engineers that are working on new products. We see a lot of repeat customers in there utilizing that capability and being able to get, you know, mandrels and wires, fine wires, you know, overnight. The second area that we've really focused on is inventory. We carry a lot of inventory. So that's one of the focuses in terms of lots of different sizes. Particularly now, we'll talk a little later about supply chain. Obviously, the availability for stock is important to make sure that we can have very competitive lead times. So we, you know, if you don't happen to see the size in that store, you know, call your DSA rep or call customer service and ask us, because we carry a lot of both uncoated and coated wire. Since we are vertically integrated, meaning that we have coating facilities and our own straight and cut capabilities, you know, we can process those orders relatively quickly and get them into your hands. And that's really what part of that inventory carrying is, because we know that you need unique sizes. And again, as Barry says, these iterations of design, hopefully we can find a size range that works into your desired need.
Very good. And actually, you know, I was going to save this till the end, but we have a live question, and somebody said that they currently use stainless steel mandrels and use a PTFE coating. The issue they have is that in some cases, PTFE flakes off after 6 months, and they're seeing greenish flakes get into the product. Can you address that quickly? And we will follow up with you directly afterwards to talk about the specific application. But I think this is one of the challenges of the standard powder coated green PTFE, which does tend to eventually flake off that way. Tom?
Yeah, I think we've heard that, over the years. I think we've definitely heard it from some of our customers that, they've had these issues where they tend to, see some debris generation and, their use in their manufacturing process. I think that's one of the key attributes. We've talked about our proprietary process, how we manage the wires and coat the wires. I think one of the things we are really proud about is our adhesion, both our durability and the adhesion of our coating to the substrate on the stainless steel wire. So definitely, we very rarely get a complaint for coating coming off. As a matter of fact, I've been here 2 years and I've never had one. So I think our product is very, very durable, and I think you'd find very successful in your manufacturing process.
Yeah, and that being said, I mean, eventually a coating's gonna come off, right?
Wear off.
So
Yep, it's gonna wear eventually.
You need to probably take a look at the cycles and other things too. And
Yeah,
finally,
absolutely.
Tom,
They never last forever, as Barry
Right.
says. So obviously you need to manage that, but it's definitely something that we think ours would typically last longer.
finally, applied plastics traditionally, we've been talking about PTFE coated mandrels for reflow processing, catheter manufacturing, et cetera. I think increasingly we're seeing a range of different applications that are popping up. Can you talk about specific, uses of PTFE natural coating as part of a delivery system? Are there particular things that you're focused on, Tom, where you see a strength?
Yeah, actually a large percentage of our products that ship today are actually either a component into a catheter or a part of a delivery system. So, it has been, obviously over the years now been used in other applications besides mandrels. Some of the characteristics we talked about earlier, I think, happen to work into, use within a component or a delivery system as well in terms of lubricity. It really helps the performance of the catheter. We've also seen consistent tolerancing, right? Our ability to deliver a very consistent product with a very lubricious and consistent process. And the other thing I think we've known more as the engineers design, smaller and smaller catheters and drive where space is absolutely, critical. Space is at a premium in that design. Our ability to hold tight tolerances has really enabled the utilization of some of our product into some very, challenging designs. And I think, those capabilities are very important. And I think the last thing that maybe you don't think about at the beginning of the design, but really needs to be thought about is scalability. So if you're putting this into a catheter, you're putting it into a delivery system where you're going to have a product launch and you're going to have a ramp up, you have to go with a partner that has the capability and capacity to, expand with you. And Applied has definitely invested significantly in capital and in increasing our capacity. So, we're very comfortable with, the demand quantities and the growth over the life cycle of your product, and can definitely have the capability to support that growth.
Great, thank you. And by the way, no, that green flaky question, that was a real question from a real member of the audience. I did not make that up. Neither did Tom.
No.
Thank you, Tom. Let's go to Noel and Forinno. Noel, we've got a great slide up of some representative formed tubing products. Forinno obviously has promoted quick turn prototyping of complex designs for many years of products that look a lot like this. How are you able to mold complex geometries with a low tooling investment and the short lead times that you talk about? And thanks for being here, of course.
Thank you, Barry. Thank you, everybody, again. Essentially, we have a heating technology that's a tabletop molding application, and we make all of our tools in-house. So we can actually take a drawing from a customer, a hand sketch or a SolidWorks model, go out to the machine shop, make a tool real quick, get it onto a bench top and run some prototypes. The best thing that we see that helps our customers get to where they need to be is going from that concept to an actual part in their hands. Getting that part in their hands usually sets us up so we can go through a couple iterations to get the part just like they want it to. We can go through these iterational steps usually in a few days. Sometimes it takes a little bit longer if the complex geometry requires us to get a mold made by somebody else, but we have partners that are close by that can get these little inserts for us very quickly.
Great, and yet I think one of the other keys is that this isn't just a prototyping technology, right? I mean, we've seen this scale into pretty high volumes.
Exactly. We can take the first tool and make the first batch of prototypes, go into clinicals, go into pilot production. Then typically we can scale up. And since we are working with a tabletop platform, we can go from one tool to as many as 20 tools with a couple operators running those. So scale is something that we're fairly comfortable with. And the applications that we choose to work on with the DSA reps and the customers are usually really focused in on our specialty technology of doing the tips, the flares. So we do a little bit of work up front to make sure that what we're going to ramp up in pilot production is something that's actually going to be manufacturable at full scale.
Great. Forinno has been really successful in modifying challenging materials, and I mean, there are technical reasons related to those, to the process and the way that you go about doing this. In many cases, engineers have used less than ideal materials due to manufacturing constraints. Can you talk about why and how the Forinno process lends itself so well to modifying materials like PEEK and the fluoropolymers?
Certainly. So things like PEEK are typically really sensitive to heat fluctuations. If you heat it up too quickly, if you cool it down too quickly, it can get brittle. It can change the crystallinity. So we try to give it the lightest touch possible. We also have very selective heat zones. So you might see somebody trying to make a part with an injection molding machine to do a PEEK part, and it'll end up with various different crystallinity because it's going through a fairly hard process to get it into the final shape. We're actually trying to very delicately push or pull the material into the shape that it's going into. And this keeps it from going into any different sort of crystallinity, causing it to have any sort of issues. PTFE and other plastics that are not necessarily known as thermally processable also work well in our processes, so we can get them warm enough to move them around, but we're not actually getting them into any type of melt temp. And this sort of experience with very gently moving around the polymers allows us to do quite a few things that other folks think are not quite achievable.
Yeah, I mean, some of these are thermostats, right? In fact, like a polyimide, which I've seen you modify as well.
Yeah, that's actually something we started doing a couple years ago that I have actually really liked, was making shaped polyimides that didn't necessarily have to be formed in a specialty shape in the first place. We can take tubular configurations and take a section of that and make it triangular or square, so that you could actually have different profiles along the length of a thermoset, like a piece of polyimide or PTFE, any of those other exotic engineering materials.
That's super interesting. In many, if you think about an inner member and middle member of a complex delivery system, there are pieces of that are, okay, sometimes metal, sometimes polymer, some places that it might benefit from incorporating both of those. Can you talk about your experience in blending multiple materials, polymers, metals, thermosets together, and how that sort of works with your process? How would that happen?
Well, it's fairly industry standard to have smooth liners like polyimide liners, PTFE liners on things. Where it gets a little more exotic is doing a joining operation from like a PEEK, for example, to a stainless steel or Inconel hypo tube. We have experience reshaping the end of the polymer tube so that it basically becomes a mechanical grip with the metal substrate. We can also incorporate little features that are basically going to make mechanical on a microscopic level interfaces between the two polymers. Once again, we go back to our heating technology, and the application of heat to the exact right temperature and the exact right place is what also allows us to put together dissimilar materials like nylons and P-baxes and polyethylenes. Sometimes some pretty complex examples. A lot of times our customers will be trying to find a lubricious property and a flexible property. And a lot of times we'll do the experiments to try to help them find a way to combine materials so that they can get pushability at the same time that they can get good flexibility. And oftentimes those two don't go hand in hand.
So fair to say that sometimes you'd be creating a component, sometimes it would lend itself more to a subassembly, and other times perhaps a completed device like a sheath or an introducer in total?
Yes, we do a fair number of shaft assemblies, dilator and other components where there might be a soft tip and a rigid section. So we take the tipping technology that we really focus in and make it so that it could be applied to a multi-component part for a customer.
Great, thank you. And I think, again, I mean, the pictures, speak very well to the capability and some of the applications there. We'll come back to Forinno on the panel. Let's talk to Mike FASCI for a minute about ACME Monaco. Mike, thanks for joining us this morning.
Great.
During your time, obviously, it's you and I have been at these companies for a long time, and your time at ACME Monaco has spanned the development and evolution of its medical business, right? Both in dental and in the guidewire business. Delivery systems are continually improving and accessing more difficult areas of the anatomy. Can you kind of talk about what changes you've seen with guidewire design during your time at ACME and how that's evolved?
Yeah, so there's definitely over the last 30 years been some major shifts and changes in the guidewire product line that we have. Starting in the late 80s and early 90s, central venous catheters, stainless steel central venous catheter guide wires were our primary market. And shortly after that, we had some customer demands for PTFE coated guide wires. These are guide wires that are typically used for urology. And we began introducing those with lengths up to about 180 centimeters. Shortly after, again, customers were looking for smaller diameter guide wires. Again, things were definitely being reduced in the size and in the vasculature that they were looking to guide the catheter through. So at that point, we were looking at guide wire diameters of around 0.18. For about a period of 10 years, we didn't see much change in the market until nitinol core guide wires became popular. And again, these were initially adopted by our international customers and then slowly being adopted by domestic customers. This particular guide wire technology, the nitinol core, was very important because there were issues typically with guide wires. You could have issues in the field due to the wire kinking if it's incorrectly used by the physician, if it comes up against something, some obstruction in the anatomy. So again, the nitinol core wire makes it very difficult to kink the wire during use. And so that became a popular addition to our product portfolio. In 2010, we came out with a new series of polymer jacketed hydrophilic guide wires. And again, these wires have a very lubricious hydrophilic coating. And this provides optimal characteristics for guiding the wire and helping it cross targeted lesions in the vascular anatomy. So these wires, because they have a nitinol core and there's no spring construction on the outside, provide excellent torque characteristics and allow for the physician, basically provide them with greater maneuverability. Over the past 10 years, though, we've definitely seen challenges being brought to us and to the market for guide wires that have interesting attachments. We have companies looking for wires that they can lengthen real time in the actual lab themselves. So wires that may have connectors on the end of them. So you can go in with a shorter wire and then put an extension on the end to increase the length. Also customers looking to install sensors in a wire. So as you can imagine, you're looking at a wire that may be 18 to 21 thousandths in diameter, and they want to actually put a sensor internal to that wire and allow for monitoring directly within the vascular system, whether it be pressure. So again, it's definitely bringing challenges to the guide wire market and challenges that we look forward to. So
that's a great summary. I mean, I think it's incredible the range of technology that is available on an OEM basis, right? It really mirrors some of the industry leaders in the direct medical business as well. You know, guide wires are unique in a way, right? These are standalone medical devices, and that's why you're an FDA registered medical device company, as well as a contract manufacturer and a custom provider to other device manufacturers. How do customers utilize the regulatory work that you've supervised and ACME Monaco has done to streamline their regulatory submissions? And is there a process, or is it that's standardized, or is that always different depending on what they're looking for?
Well, typically, depending on the construction of the wire, in many cases, the device or the guide wire that they're looking for may fall currently within our 510K approvals. So in that case, we worked with customers and provided right to reference letters so that they can leverage the work that we've done in our 510Ks in order to get approval or assist in getting the approval for either their 510K or their regulatory submission. In the event the device falls outside the 510K that we currently have, again, we have an internal regulatory team that is available depending on what the customer's level of need is. Again, we will go to whatever level they require, whether it's just developing technical documents for them, or even actually working on the submission for the 510K. So again, this is typically a regulatory service, I guess you would say, that we definitely offer to our customers. And some customers that do not have the ability to have a large staff of regulatory personnel, this definitely helps out the new companies trying to bring products to market. So.
No, absolutely. I mean, for sure, people are hiring external regulatory experts and being able to fold that into a particular device. That seems like a great way to go. Finally, Mike, if I can, I'd like to ask you about capabilities beyond guide wires. We're obviously focusing on those and in particular the nitinol core capabilities, but wire forming capability and stamping capabilities at ACME are quite significant. Can you talk about how those are brought in and how those are utilized to help medical device customers?
Sure. So the basically ACME Monaco's roots, starting back in 1947, again, started with fine wire forming, coiling, shaping, and stamping. So again, our expertise is in the manufacturing of precision metal components, and typically starts with either fine wire straightening, forming, again, stamping or coiling. So we've been able to leverage technologies that we've used initially in the commercial industry as we brought on the medical devices. Some of those, although slightly different in the equipment makeup, definitely helped us leverage our past experience. Again, we have medical customers that are in all facets of our business. Many purchase other components far beyond just the GUIDEWIRE product line. Parts such as catheter reinforcement springs. We could be talking about compression springs that are used in medical syringe units, spring stampings in medical delivery devices and testing devices. And again, stampings for orthodontic applications, as well as wire forming, straightening used in like bone pins. So each of these products, they definitely leverage the roots of the organization and the specialty that we have with the fine wire and flat stock components.
As you said, the roots, the valley where ACME in Monaco is located has quite a history in this business. Huh?
Yes, correct.
Well, great, thank you. And now let's move on to M3 Precision and Mark Sorensen. Mark, I wanted to talk specifically about Swiss machining, and lots of times, lots of terms that people use, number of axes, the spindle size. Are all Swiss screw machining centers capable of producing similar parts, or is the place to start? What type of equipment do you have when folks are considering where to take something?
Yeah, there's a lot of things to consider when sourcing CNC Swiss components. The complexity with the part is parallels the axis of the machine. The more complex the component, the more axes are required to make the part. Our axis capability goes up to 8 axes, which allows us to have 3 simultaneous axes in the cut, and that allows us to do things like helical patterns on a cylinder or hex patterns, lobular patterns. We try to work with our customers initially to make the components fit on the capabilities that we have. The other big thing to consider, which is universal to all parts in terms of complexity, is the ability to hold the part once it's machined. In other words, to pick the part off, whether we're doing work on the sub spindle, the pick off spindle, or just picking it off and ejecting the part. The shape of the part, we need to integrate some type of shape that is able to be culleted or picked off. And that's regardless of the complexity of the part.
Interesting. I think it's a great lead into the next question that I had for you. I mean, one of the difficulties in designing machined components is that many engineers have either not done the actual machining themselves and had that experience on Swiss machines. CAD allows complex geometries to be modeled with relative ease. Basically, you can design anything, but manufacturing some of those designs can be challenging, if not impossible. I think on the other hand, right, the capabilities of some of your newer machines go way beyond what people may be familiar with in earlier generations of Swiss machines. Can you talk about how you work with customers to ensure that they're both creating designs that can be machined while also making sure that they know about how complex they could actually get?
Right. Yeah, I mean, ideally, we're involved at that initial DFM level and can contribute to the engineer's understanding of how our machines work. And when we get to that level, it really benefits the DFM process. Things like features, and this is in the range of size. We produce parts from a 0.5 millimeter to 32 millimeters in size, and with features down to 6,000 in that range. It's good to understand how those features are produced by understanding the way the machines function. And sometimes we've actually sent our customers videos so they can have a better understanding of what a multi-axis Swiss does. It helps them design the part accordingly. Things that we like to talk about when we're involved at that level in the early stages, number one is material. If we can have input on material, we like to steer customers to materials that are more machinable. And that's always a cost driver, particularly when things scale up. And another big factor is features that intersect. We see a lot of small components that have intersecting features, a threaded hole into a slot per se. And anytime we have features like that, we create sharp corners that are an issue. And particularly on small parts, those type of features are difficult to deburr. And if it's a challenging material to machine, that becomes even more difficult. So those typically are the kind of things if we can, we like to have input on early to help design in a feature that is more cost effective to process. The third component of that, go ahead.
No, please.
And the third component is the aspect of the part that we need to be able to pick off, to be able to hold the part in the subspindle. Again, whether it's to work on the backside of the part or just to pick it off. We don't necessarily need to pick off on a round diameter. We can pick off on squares or rectangles or odd shapes. That just requires a custom, typically EDM pick-off, call it. But we need some feature that is integrated in the part that we can actually grab and call it the part to pick it off with.
Very good, thank you. And I think the accessibility of you and your team, Mark, to help make those things is really critical. Finally, there are some parts here that inform this, but you talked about that material choice. Many of us think of metals when we're thinking about machining a part, but you have extensive experience in machining medical approved polymers as well. Are there advantages of machining over injection molding of polymers? And I know obviously there are differences as well. There are specific grades of plastics that can be machined and others that are really good and others that are really bad. You want to weigh in on that?
Yeah, we've had exposure to an array of plastic machining parts, from the simple ABS, nylons and Delrens up to the peaks and Teflons and Kynars. We've been involved with some projects that we thought we were prototyping and just helping get a design lock for the customer, and 5 or 8 years later we're still machining the parts, either because they've evolved the design and don't want to lock in on the cost of a mold, or it's just been cost effective enough as it scaled up in volume for us to produce some a screw machine. The other areas that we've been able to continue with production beyond prototype levels are with some plastics. We've done a Kynar part for about 15 years for an aerospace project that I guess that material just doesn't, it's very tough to mold. I think at temperature it gases and corrodes everything. So there's applications that just because of the difficulties with molding and our cost effectiveness, I think we've had some success at surprising our customers with our our price point, particularly in volume, with competing with a molded part, and saving, giving them the ability to change a part and not have that initial large investment in molded tooling. It has to be the right part and the right fit, but there's definitely quite a few applications where we've got some 15-year ongoing medical plastic parts that we thought would have been gone many years ago, and we continue machining them.
Great. Mark, thanks so much. I'd like to move on to our panel discussion, and we'll be bringing everyone back onto the main screen. Oh, actually, we're all on the main screen, but we'll have a little more visibility for everybody. Gentlemen, I want to start off with a few questions about choosing the right production process, about prototyping methodologies, and design for manufacturing. I'll probably direct them at one of you to start, but please do jump in with your thoughts at any time. And for our audience, please remember to put your follow-up questions or any questions for the panel in the Q&A section at the bottom of your screen. So here we go. Most of the things that we've talked about rely on specialized, expensive capital equipment for manufacturing. The systems allow for high-speed, low-touch processing. For example, at ACME, you have high-speed coiling equipment producing up to 30,000 parts per hour, 14-axis CNC machines with outputs for complex springs and wire forms. Mike, I'm going to throw to you. I mean, can you talk about your approach to maintaining steady state of production for customers? And also, we'll come back and talk about how to scale up to those type of systems. But for now, let's talk about the high volume stuff if we can.
Great. So one of the things that we do is try to keep as much uptime as we can. Currently, our facilities, they operate at 3 shifts a day, or full 24 hours a day. We also basically have 3 manufacturing facilities, which are all running guide wires. So in the guide wire sense, we basically can run guide wires in any facility, which will provide us the flexibility and the redundancy of and contingency of having additional facilities to run same type products. Depending on volumes and complexity, you talk about tooling, specific tooling. Again, we have part-specific tooling, we have generic tooling. Basically, with all that tooling, we definitely keep redundant spares to prevent any downtime, unnecessary downtime. And in a lot of cases, our internal tooling and consumables are kind of built into a Kanban system so that that could minimize downtime and keep track of when reorders are required. So.
Great. Mark, I think you obviously spent some time talking about high volume. Would anyone else like to address that? Tom?
Yeah, sure. From an applied plastics perspective, you know, we've continued to invest in the business. So we do have specialized equipment. It's all custom made. So we've been, you know, very proactive with adding equipment and adding capacity to manage that. You know, similar to Michael, we have automated processes, so we like to keep them running longer. So, you know, currently we operate 16 hours a day, so we don't have a 24-hour shift yet, but we did add a second shift last fall to, again, stay ahead of the capacity and stay ahead of the demand that we knew would eventually come back as part of our turnaround here and that we've seen the last several months here. So, you know, I think the other thing is, as he points out, is our ability to be flexible with training and add overtime and things like that helps us, you know, be able to respond quickly to our customers, and the vertical integration that we have with our ability to straighten and cut our own wire also helps us, again, service the customers a lot better.
Mark, do you want to talk about your favorite screw machine? Can't hear you. There
we good?
Yeah.
We've evolved over the years in capability in terms of complexity and multiple axis. We've, in the last 4 years, added 5 of the 8-axis machines that allow us to, they're very similar to the 6-axis machines on the main spindle, but on the sub spindle on the back of the part that we picked off on, we basically have the same tool count and tool capability to the same type of features on the front part of the part, on the back side of the part. That allows us to do more complex parts, but it also allows us to split the cycle time, basically. Ideally, when we see a complex part, the first thing I do is look at splitting the work between the spindles. So ultimately, we're doing the work on the sub spindle or half the features on the part for free time, because it's taking that same amount of time to do the work on the main side. And we also like to inject that mentality at the design level, because ultimately it produces the most cost-effective components.
Great. Yeah, thank you. We move on to design for manufacturing, which a couple of you guys have brought up. You know, frequently you have a specific expertise in the component, in the coating, in the material that can help someone if it's actually incorporated into that design. Maybe not the first moment that they sketch it out or their first go around on the print, but can you talk about what you typically see when a part is brought in? Is it cleaning processes that you want to talk about? Is it inspection methodology that you want to consult with customers before they lock those in? Is it materials? And finally, how do you bring that in and incorporate that? Is it through iteration? Is it a consultation with your engineering team? What's the best way to do that for a part? Noel, you want to start with that?
I think that discussion needs to happen right off the bat with pretty much all of the elements that you brought up. First, trying to find out, is the customer going to be using this for a ramp up, or are they going right into a product that's going to have some volume to it? Really lining up on inspection techniques is a big part of it. Many features that engineers are designing now that are less than 20 thou in diameter end up being something where you start looking at measurement capabilities and then you start talking about functionality. So we usually try to balance out what the customer's end goal is and then really try to hone in on the reality of what the specification is and how you're going to measure it. A lot of times we're dealing with parts that have been drawn in SolidWorks. You can blow it up to 200x, look at it, and it makes complete sense. But when you try to make it out of a plastic part, it ends up being hard to distinguish whether it's flash or actually a part when you're looking at something that it's extremely small. So on the small things, I think usually a lot of time it's an alignment conversation between our engineering team and the customer on exactly what function they're looking for.
Very good. Anyone else have some thoughts?
You know, Barry, this is Tom. I think, you know, anytime you can tackle something up front in the design before it's frozen, it's obviously an easier discussion, and you can have some trade-offs at that point in time. So again, as Noel said, the more discussion you can have up in front, particularly when you think about stacking of tolerances and how they relate to the different components, it's much better to have those early on, and then we can, you know, iterate with them and give them options to try and work out in their processes to hopefully, you know, come up with a much more efficient process.
Oh, and I think you guys bring up a good point as well. I mean, there's sort of DFM that's built in if someone is starting really early with you as the supplier, right? And then it's a whole different thing when maybe you've done the prototyping, you've printed some parts, right? They seem to work. You generated you've got a print. It's ready for, you know, either serial production or at some point, and then you just basically get handed this thing. and you have to comment on it, red line, etc. That's all, I think, a whole different thing. Mike, can you talk about that perhaps as where you want to jump in and how you engage with a manufacturing engineering team at that point? And you are on mute.
I mean, it's definitely very important. We see it quite often when customers are bringing new products to market, and they build a design, a blueprint, and they have certain specifications that they build into that blueprint, whether they be in the notes section, and we can use, for an example, a cleaning process. You know, they may define a specific cleaning method, they may define a specific cleaning chemical, when really what they need to determine is more of what are you looking for in the end? What is it, the bioburden level, particulate level on the product? Is it visual, you know, the cosmetics of the product? So, you know, that's where we try to work with the engineers to make sure if we can leverage an already biocompatible solution that the customer can adopt, we try to work with them to build that into the actual specifications. Because often we find that, again, they may not be experts in the field. They may be expert designers, but not necessarily experts in the actual, whether it be metals, fine metal forming. So we try our best to, you know, work with the customers, and that's something that we actually request from all our new customers, is get us involved directly in the design stage, because we could definitely help in not only making sure that we have a robust product, but also make sure that we can provide them with a cost-effective product, because often very small differences in what the customer is asking for and what we can provide could have a big cost impact on the customer and their customers in the future.
Great. I'd like to hear some more from each of you about how you approach prototyping and small volume scale-up. You know, some of these processes are great. They scale on their own, as we've talked about. Others really, maybe not so much. I know all of you have gotten really creative about making representative products available, either off the shelf or with quick turn. What are some of those challenges? How can you individually help get your customers something really fast, really on point, and move that design forward? And maybe this is a good place to talk about how you're currently using 3D printing, other types of digital modeling, anything else that you've seen that really helps move things along. Mark, you want to start?
Sure. So our facility here, being strictly Swiss, we really don't consider ourselves a prototype facility, but we do prototype, and we do it with the intention to scale. The somewhat of a limitation for us here is that when we do a 10-piece prototype, we are going to machine that and process it identically to 10,000 or 100,000 piece part. There's a benefit in that there's no process change along the way. The downside typically for us is lead time, and it's not sometimes the most cost-effective way to prototype as well. We do work with the other facility who is more flexible at turnaround on parts that aren't necessarily Swiss parts. If we can do it in a mill lathe operation to produce a small quantity quickly and start the iteration and change process back and forth, we'll use the Santa Maria facility. But in most cases, the parts we see at that kind of developmental level are Swiss type parts, and we usually go that direction and try very hard to meet the lead time demands. That's typically where we're going to have the biggest issue on a development project.
And what do you think about the, certainly the advances in metal 3D printing? Are you seeing people successfully incorporate that to make one or two of some pieces?
Yeah, our Santa Maria facility is doing more with the 3D printing at a prototype level. In the Swiss world, unless you're talking about a very high dollar, high end 3D printing machine, we've seen very little applications where we could 3D print a part that was anywhere relevant to what the customer's looking for. And beyond that, where our Santa Maria facility looks at 3D printing as something we have to integrate to stay relevant in the future, in the Swiss world, it's really not an issue. It's not a threat to our technology. It just doesn't really apply in our world.
Interesting. Noel, how about you?
Well, it's interesting what Mark says about the 3D printing and how it applies to the world that we exist in medical devices. The first drawback to 3D printing is that you have multiple layers and you have a limitation on how sharp you can make corners and if you can make undercut geometries. We've been working with 3D printers quite a bit to make prototypes for things, but we oftentimes avoid making any sort of mass-produced part to give to somebody on a 3D printer because they tend to be something less than what you would get from an actual molded part or a Swiss machined part, for example. A lot of times people think that once again, you can take a drawing from SolidWorks, throw it on the 3D printer and it comes out exactly the same. That's not exactly it either. A lot of times our customers are looking for parts that have tight tolerances on holes and they're gonna fit well with other parts. The 3D printers, even the super fantastic hundreds of thousands of dollars ones end up with minor fluctuations in the output that you get from the drawing that's put in. So we end up having to take the 3D printed parts that we make and tune them in so that they're kind of crafted to work for the customer. And so it takes it away from being something that's a perfect one-to-one tool for prototyping to being something that is still takes a little bit of finesse to get it to the 3D printed part to work. We work with regular filament printers and cast part printers, so we do get some pretty high resolution out of them, but we're looking forward to the next generation of 3D printers to be able to make parts that could be comparable to molded or Swiss machine parts.
Very good. Tom?
Sure, I think I had mentioned a little earlier, we have an online store where we'll help the design engineers iterate the sizes, whether, what exactly do they need. So we're able to ship that very, very quickly. The advantage there is that's all commercial product, meaning that comes through our commercial process, rounded end, CFC comes with it. So it does facilitate that transition, from the lab into production, because it's going to be the same, the same coating, the same mandrel, basically the same process of that fine wire, so that hopefully that transitions from design into manufacturing that much easier. The other area that we have focused on as well, which is we're seeing more and more demand for, is around custom mandrels. So shaped mandrels, tapered mandrels, where we've kind of dedicated an application engineer and some resources to help with that quick turn aspect, to be able to try to maintain faster turnaround for some of those specialty custom mandrels. So that's an area of focus that we've had, and again, maintaining a quick lead time and a turn is also, hopefully helps our customers iterate in that type of environment as well.
Very good. Anything you wanted to chime in with, Mike?
We're fortunate enough that most of the prototypes that we're required to build are similar in nature from our standard products. Usually, a step or two more difficult. Typically, the newer products that are being prototyped are definitely miniaturization is one, and complexity is two. So, again, we try to focus on exactly what the customer is looking for from a performance standpoint, and we have a full R&D staff that with tool makers, we have tool makers, tool designers, electronics engineers. So, you know, we'll do anything from modifying a current process to building new equipment, new tooling internally for the customer for these prototypes. So being able to do a lot of the work internally allows us to get quicker turnarounds for our customer and provide them with a quick prototype to evaluate and then come back and determine changes that may be required.
Very good. We have had a couple questions about supply chain and minimizing disruption, how those are integrated. I want to kind of combine that with a question about assembly and other capabilities that you have that go beyond what we've talked about, right? Your core capabilities. Obviously, each one of you have these specific technical expertise, but I know that, you know, all of these companies, all of you are managing programs that go way beyond that, right? Where customers have, for instance, Forinno has integrated assemblies that involve molding, adhesives, pad printing services, outsourced parts, and then brought those in to a complete assembly. Can you talk about how that supply chain integration piece works for each of you? And do you prefer to do that? Do you see that as a help to the customer? Or are we, you know, is the focus on an individual part best for you?
I guess I'll hop in on that one. We oftentimes are working with other suppliers for our tubing. We'll do our operation, get a part laser printed or pad printed. We usually try to take it to the point where it fits in with our customer's application with minimal work on their end. Our philosophy is essentially the customer is working on a technology that does something therapeutic for a person, and we're doing something that is helpful to help enable that customer deliver their therapy. So we're happy to work with molders and everybody else out there, especially the partners on the DSA team, to bring parts in, put them together, and then get them into the customer's hands so they can focus on what's really important to them.
You know, from a standpoint of coating, obviously we put coating on, but you know, recently we've been asked quite a bit to take some coating off. So different areas of the, you know, the wire might need, you know, bare metal to do subsequent processing on. So, you know, we've obviously we're happy to, you know, make that type of service, supply chain management of that, whether it's, you know, laser ablation or mechanically removing some of the coating to, you know, simplify the next step in the process. So that's something that, you know, we've been additionally asked for a lot more recently, but it's something that we typically will take on.
And then we at ACME, we will integrate different products. Again, some of our guide wires, they require special plastics, packaging, and dispensing. So again, we work with our supply chain to provide those components. Again, plastics are not our expertise, and we want to leave it up to the experts. I mean, we have a good supplier base. Tom, we purchase materials from Tom, coated mandrels. So again, there's a lot of opportunities with good suppliers out there to, if it makes sense, look to integrate it internally. But in some cases, depending on the expertise level, it's better just to source the individual components, and either the customer decides to do them internally if they feel it's cost effective, or ACME will also work to build and assemble things internally for our customers.
Very good. And Mark, I think certainly that applies for the Santa Maria facility a lot more than for your Swiss business, right?
Yeah, absolutely. Yeah, we are able to utilize the Santa Maria facility for machining operations that we're not able to complete here, such as wire EDM or grinding. But we try to take on work that we can complete internally, other than coating and heat treating and finishing process that we have a pretty robust supply chain for those kind of outside processes.
Very good. Wanted to talk about materials, and particularly in the metals and in the plastics business, in the raw material supply. There have been tremendous fluctuations in lead times and pricing that are interrupting the ability to rapidly prototype for many of our customers, perhaps many of you. Can you talk about what is important to you? What information customers can provide to you to help mitigate or manage those commodity supply issues? And also, if you can weigh in on what you're seeing right now in key, markets that are important to you, that would be great.
I'll be happy to start.
There you go.
Definitely escalating prices and lead times is something that we're dealing with currently. Materials, typically 3 to 5 weeks would be standard lead time on raw materials, and we're seeing suppliers respond with 20-week lead times, which haven't seen in 30 years I've been at ACME. So it's definitely challenging. It appears that, during the pandemic, something stopped and it's very difficult to get it restarted. And so there's really high demand for materials, and, vendors that we've been able to get on the phone and get materials right away, they're telling us they don't even have access to the materials. So, the information that we're trying to provide our customer base is the farther they can forecast out, the farther they can provide commitments on materials, the more assured they could be that they're going to have product when they need it. And it's not, it hasn't been more important in the past than it is right now.
I think I would echo what Mike says there in regards to, just the lead times that we see continually getting pushed out. And, that's a challenge for all of us. So the more information we can have, the better off we can plan, and hopefully we can work with our customers to, manage that demand that's out there. The other thing we're seeing quite a bit is, again, just lead times amongst our suppliers, right? In terms of where they might even have the materials, but from an order demand perspective, their lead times are going out just because of the volume of some of the opportunities that are coming back in the space. So their lead times are going from, as Mike said, what might be reasonable, 3 to 4 to 5 week lead time to 6 to 8 to 10. So it's definitely a challenge. And right now I think it's it's going to be here for a while, because it just feels like everyone is getting busy at the same time. So I think that's from a planning perspective, really, as Mike said, the earlier they think through, what that forecast is, what that future looks like, the better off we all are to helping them get through, this high demand period.
Obviously, I would say, placing those orders out, if you have a production product, this is the time to do that. And at the very least, I know, I won't speak for everyone, don't quote me, but generally, right, you're willing to make some accommodation for fluctuations in future forecasts, for, commitments to cover material costs, to do other things, right, that will allow you to lock these things in, right? Because people have, right, we'll be worried about committing to a purchase for a year out or a year and a half out, but maybe they'd be willing to commit to covering the material costs or WIP or something else, right?
Yeah, we're all willing to share in the balancing that, right, and understanding what that demand is and how firm they feel it is. We're absolutely willing to share in those types of decisions, because I think it's in everyone's best interest to work together in the period of this high demand. So it's absolutely something I think, based customer by customer, we can work through and find out the best solution.
Mark, how's this impacting you guys in terms of availability, particularly of specialty metals?
Yeah, we're seeing some real issues with stainless and titanium. We had meeting with our purchasing guys and planners last week because we were somewhat blindsided with some ongoing contract stuff and went literally the same thing Mike and Tom were saying with a typical 2 to 3 weeks. We have a lot of stuff that comes from Europe, but it is warehoused in Chicago, and we're 2 weeks out, 3 weeks out typically. And this is repeat stuff where we're buying 10 or 15,000 pounds of material. And we just with no notice, we got an email that some of these sizes and alloys were going out to 20 weeks coming from overseas. So we've had to scramble to stay in production. We can't at this time pass any of this on to our customers. So we're doing things like buying oversized material and filling up our chip bins a lot faster than we'd like to, because we have to stay in production and we don't have an alternative. We've reached out to all of our suppliers and asked them for a forecast and to ask them to be more proactive. I mean, we're not the experts, they're the material guys, yet they're not, and we have long ongoing contracts and relationships with them, but they're not very proactive about reaching out and letting us know what's not coming down the pipe. So we've had to react and really aggressively try to understand what things are looking like. And we've let a couple of our customers know that we really need some good forecasting from them if possible, so we can buy way ahead.
Yeah, I think that there's a level of pain yet to come that hasn't really, hit. I know that we have not been passing along for most of you, significant price increases, but and I know nobody really wants to do that. Actually, it's hard to imagine that that's not going to be happening at some point soon. Noel, how about you in terms of particularly specialty? I mean, you tend to buy small quantities, specialty materials. What are you seeing?
The polymers are a challenge also. We've seen lead times go from the standard 3 or 4 weeks to 7 to 8 weeks for things like peak extrusions, other types of what you would think would be pretty off the shelf sort of things. That's a place where we've been able to kind of leverage our specialty technology. We can take materials that are close to the right size and get them sized so that they are exactly the right size. So that's actually a little benefit that we have. People can send us tubing that they have that might be needing a little bit of a tweak, and we can do that. The real concern is when is it going to start getting back up to speed? We have heard from some of the large plastics manufacturers that due to some of the natural disasters that happened last year, that there have been some output issues there, in addition to just shutdowns because of the pandemic. So this is something where we're also going to our customers and saying, hey, we need to try to work out as long of a forecast as possible. We're also buying things at risk so that we can be ahead of the curve and have materials for our critical customers out there.
Yeah, I think it's quite an interesting situation that everyone's in right now, and we'll have to sort of see how that all plays out. Before we wrap up, I wanted to also ask each one of you to talk about what you're most excited about, say right now, aside from actually seeing people, but in your business. I mean, are there things that you just go, wow, this is such a cool thing, I can't wait to do more of this?
Again, I'll be happy to start. We've been experiencing over, I would say, the past 6 to 8 months, definitely an increase in prototype requests, new product development requests. It appears that maybe there's been additional time because the market itself may have slowed down in some cases, but for our, for the guide wire, from the guide wire perspective, because of the pandemic, it was of high demand, and we actually saw larger orders in guide wires than we have in the history of the company. So, so for that particular product line, again, we were trying to keep up with the demand, and now we're seeing some very interesting new designs in guide wire products that are used for, again, guiding catheters into the heart, products that are used, again, like I talked about, with extensions and just things that 5-10 years ago you would have never thought possible to be able to produce. Not even the fact that you would think that they would ever exist, but to the thought of putting a sensor inside of a wire to place inside your vascular system, and then a specific point within your vascular system get a pressure reading, a blood pressure reading, is just that technology definitely is futuristic, and we're looking forward to it, and we're pretty excited for new products and requests that will be coming in from customers and new potential customers.
Great, thank you, Mike. Tom?
Yeah, one of the areas that we've really been pleased with is the online store. We've love to see, our customers going in there time and time again, grabbing stuff off the shelf, both domestic and internationally. So, what we've really done is we've taken a step back. We've done some customer surveys. We're going to add to that store, see what other sizes we can put in to really, maybe beef up their capability and address some of the other growing markets with different sized, fine wires and coated mandrels. So we're really excited about how that's done, and we think that's a great way to get, quickly get products into the hands of our engineers so that they can be more successful in designing the next best catheter.
Thanks. How about you, Mark?
We're just excited to see the little uptick we've seen in new project work. For whatever reason, through the pandemic, our production work, our higher volume work stayed really steady. We're not sure why, but we saw a dip in new opportunities and new projects. And at the late first quarter, we started seeing an uptick with that, and it's continued. We're excited that it's back going the right direction for us.
Very good. Noel, you get to wrap it up.
All right. Well, we're actually really excited about the growth that seems to be coming out of the 2021. We've got a lot of experience helping develop products from the sketch phase to the production phase, and we usually see that takes 3 to 5 years. So we had a lot of products coming into the pipeline before 2020. It was a little bit of a hold your breath moment to see where things were going to go after that. We did see 2020 turn out to be a good year, and what I'm really looking forward to is adding to our team and to adding to our space to be able to take it from that early stage development to the production that we've been looking forward to for a few years now.
Very good. Thank you all, and thanks so much for the great discussion. We have a couple of questions from the audience that are pretty specific, and we will definitely get back to you on all of those things. So questions about specific wire, about application, and others, will have some follow-up for you in the audience after the panel. I hope you've enjoyed the panel today. We certainly have, and we've tried to give you just a taste of the resources and capabilities, accessible to you through the DSA partnership network. We're really proud of what we can offer together. And again, if you have not met your local DSA rep, I hope you'll reach out, and when they try to bug you, just at least schedule a couple minutes for them to chat with you. The resources that they can go in and help you find at these amazing companies are really something special. So remember to tip your servers, check out our website, go visit these partners, and we hope to see everyone soon. Thanks again for coming to join us today.
All right. Thanks, Barry. Thanks, everybody.
Thanks so much.
Thank you all.
Thank
So
you.
long.